This is the third and final class of the chapter Quadratic Equations, and this is going to be a little bit bigger and elaborative class because this particular part of the topic needs a little bit of discussion. Today we are going to discuss the relation between the roots and the coefficients of a quadratic equation. So to begin with, let us take a quadratic equation ax square plus bx plus c equals to 0, and let us consider that alpha and beta be the roots of the quadratic equation. Doesn't matter if they are real or complex, it always remains the same. Then this quadratic equation ax square plus bx plus c equals to 0, I can write it as x square plus b by a x plus c by a equals to 0. That is basically I am dividing the whole equation by a. That is, I am just keeping the x squared term free of any coefficient. Then as we have alpha and beta, two roots of the quadratic equation, then definitely I can write the factors of this quadratic equation as x minus alpha into x minus beta. Means I can separate out the factors as x minus alpha and x minus beta. Then if I multiply these two, this is what I get: x square minus of alpha plus beta into x plus alpha beta equals to 0. Now I have marked the first equation as 1, the second one as 2. Now these two are basically the same equations. So from here, if I compare, I can write alpha plus beta, that is equals to minus b by a, and alpha beta, that is equals to c by a. So this is our relationship between the roots and the coefficient. So this is the relation between the roots and coefficient. Fine. So we are going to use these two formulas throughout our different problems, the examples that we are going to solve, and these are the only two formula that we have. Now let us take the first problem. The first problem is write the sum and product of the roots of the following equation, and this is our equation: root over of 2x square minus root 2x plus 4 equals to 0. So now if this is the equation given, so let us compare with the ax square plus bx plus c equals to 0 and write the values of a, b and c. We require them. Now we know sum of the root, that is minus of b by a. So from the equation we know what abc is. So from there we get the sum of the root as 1, and product of the root is 2 root 2. Right? Minus b by a and c by a. Pretty easy to see. Next, number 2. Now question number 2 is going to give us the idea of how to make use of the sum and product of the roots. It is given if alpha and beta are the roots of the equation 3x square minus 6x plus 4 is equals to 0, then evaluate alpha square by beta plus beta square by alpha plus alpha by beta plus beta by alpha plus twice of 1 by alpha plus 1 by beta plus 3 alpha beta. Now this can be done in two different ways. Now the two different ways being that you can always make use of the idea of sum of the roots and product of the roots, and also you can do what you can individually find the roots and put the values here. So both ways it can be done, but let me tell you, if you try doing it by finding the root, then I can assure you that it is going to be a little bit difficult to work with, because there are so many places you have to put the values. But if we can do some manipulation to this and then apply the sum of the product and sum of the roots and the product of the roots, then the whole thing can become a little bit easier. So let us start off with the expression that which we have to work with. Now before that, let me just write down what is the sum of the root and what is the product of the root. So from the equation I can see that the sum of the root is 2 and the product of the root is 4 by 3. So now once we start off with the expression, now obviously you can see, to apply sum of the root and product of the root, I must have that expression present. So alpha plus beta and alpha beta, these two expressions must be there in the whole expression. So let me just go on manipulating. So let me first take LCM. After taking LCM I get this, and from here alpha cube plus beta cube, I can write it as alpha plus beta whole cube minus 3 alpha beta into alpha plus beta, and alpha square plus beta square, I can write this as alpha plus beta whole square minus 2 alpha beta. So let me just do that manipulation. Right now if you just look into the expression, that the whole expression is made up of alpha plus beta and alpha beta, that is the sum of the roots and the product of the roots. So now we definitely know the values. So what we will do, we will just put the values and calculate, and we are done. So let me just put the values. So this is what it looks like after putting the values. Now this is now a simple calculation. Go on doing it. Once you do it, you will see that the answer is 8. Just give it a check. I think I have done it correct. If I have not, please let me know. Number 3. If alpha beta be the roots of the equation 3x square plus 2x plus 1 equals to 0, form an equation whose roots are 1 minus alpha by 1 plus alpha and 1 minus beta by 1 plus beta. Now this is the equation given, 3x square plus 2x plus 1 equals to 0. So once again, you can always find the roots of the equation, that is find the value of alpha and beta directly. From there you can calculate what is 1 minus alpha by 1 plus alpha and 1 minus beta by 1 plus beta, and then you can put it in the equation. But it is easier to make use of the sum of the roots and product of the roots. So from the equation we can see that sum of the roots is minus 2 by 3 and product of the roots is 1 by 3. Now let us consider the new equation which we are going to form. Their roots be gamma and delta. So gamma is basically 1 minus alpha by 1 plus alpha, and delta is basically 1 minus beta by 1 plus beta. So to find the equation, first we need to find the sum of the roots and product of the roots of these new equation. So let us first find what is gamma plus delta. So the only thing we need to do here is take the LCM, means add them up, take the LCM, do a little bit of calculation, and by doing a little bit of calculation we can see that the sum of the roots of the new equation is 2, by putting all the values at one place. And then product of the equation, product of the roots, it's coming to be 3. Very clear to see. Just put the values and calculate, you will find it. So now once we know what is the sum of the roots and what is the product of the roots, then we already did this, that if alpha plus beta is the sum of the root and alpha beta is the product of the root, then the equation is given by x square minus alpha plus beta x plus alpha beta equals to 0. Fine. So therefore, in this case also we are going to do the same. and hence our equation is x square minus 2x plus 3 is equals to 0. Fine. Just give it a look, give it a try. I'm sure you will be able to do it. Number 4. Determine k if one of the roots of the equation k x minus 1 whole square is equals to 5x minus 7 is double the other. So it is already told that the equation has two roots, one of which is double the other. So in that case, I can always consider one root as alpha and the other root as 2 alpha, right? Now let us find what is the sum of the roots and product of the roots. So sum of the roots, now in this case one is alpha, the other is 2 alpha, so therefore sum of the roots is 3 alpha, and 3 alpha is nothing but 2k plus 5 by k, or in that case alpha is basically 2k plus 5 by 3k, and product of the roots, that is 2 alpha square, that is equals to k plus 7 by k. Now I already found out the value of alpha in terms of k, so let me just put it in this second one and then solve for k. Right, now it will be some routine calculation, just do it. From here I get this k square plus 23k minus 50 equals to 0, and from here if you just solve, the value of k comes out to be minus 25 or 2. Fine. Next, number 5. Find the condition for the equation ax square plus bx plus c equals to 0 and a dash x square plus b dash x plus c dash equals to 0 to have reciprocal roots. Now reciprocal roots means if roots of one equation is alpha and beta, then the roots of the other equation is 1 by alpha and 1 by beta. Right? So if alpha and beta are the roots of this equation, then 1 by alpha and 1 by beta are the roots of the second equation. So from here let me find out what is the sum of the roots and product of the roots. So for the first equation, sum of the roots is alpha plus beta, that is minus b by a, and for product is c by a. And similarly for the second equation, the sum of the roots is minus b dash by a dash and product is c dash by a dash. So now let us establish the relationship between a, b, c and a dash, b dash, c dash. So we have 1 by alpha plus 1 by beta is equals to b minus b dash by c dash. So if I take LCM and write this, then I have alpha plus beta by alpha beta, that is equals to minus b dash by a dash. And then what is alpha plus beta? That is minus b by a. And what is alpha beta? That is c by a. So we can write this as b by c. If I put the values on the left hand side, it becomes b by c. So from here I can write that a dash by c is equals to b dash by b. So mark this as number 1 and let it be. Then in the second case, 1 by alpha beta is equals to c dash by a dash, or we can write this as a by c is equals to c dash by a dash, right? So from here again I can write a dash by c is equals to c dash by a. Just follow the relations as it is given. So from the first one and the second one, I can write a dash by c is equals to b dash by b is equals to c dash by a. I should have marked this one. I just forgot to mark. So this should be 1 and this should be 2. So from 1 and 2 we have this. right? Now let us move to number 6. Find the value of k so that the equation x square minus 11x plus k equals to 0 and x square minus 14x plus 2k equals to 0 may have a common root. So here I am trying to find the value of k given there is a common root. Now common root means the value of the root is same for both the equation. So therefore let us take delta to be the common root. It's just any Greek letter you can take as a root. Now obviously if delta is common root, then definitely it must satisfy both the equations. So it satisfies the first one, so therefore delta square minus 11 delta plus k equals to 0. In the second one also delta square minus 14 delta plus 2k equals to 0, right? Now let us do something. Let us subtract the first one from the second one. So if I do so, or the second one from the first one, whichever way you want, then if you do so, you can see you get 3 delta minus k equals to 0. So delta is equals to k by 3. I get the value of delta as k by 3. Now from here, once I found out that delta is k by 3, I can put this value back in any one of the equation and solve, and if I solve, I will get the value of k. So let us put in the first one. So k by 3 whole square minus 11 into k by 3, that plus k equals to 0. Then again that gives you k square by 9 minus 8k by 3, that is equals to 0. So from there I get k square minus 24k equals to 0, and hence the value of k is either 0 or 24. Fine. Simple problem. Next, number 7. If r is the ratio of the roots of the quadratic equation ax square plus bx plus c equals to 0, show that r plus 1 whole square into ac is equals to b square r. Now r is the ratio of the root. Ratio of the root means, now if one root is a or alpha, then the second root can be considered as alpha by r or alpha into r. That is what the ratio means, because if I have the roots of the equation as alpha and beta, the question says alpha is to beta, that is equals to r. Now r means obviously r is to 1. Obviously when there is to 1 on the other side, you need not mention is to 1. You can always say that it is r. So therefore if this is so, then alpha by beta is equals to r, or therefore I can write I can write beta as alpha by r. Now here it matters if I am going to take r is to 1 or 1 is to r. In both the cases I am going to get the same answer. In that case I will get beta as alpha into r. So both are fine. So when I am said that r is the ratio of the root, I can always consider it as r is to 1 or 1 is to r. Both are going to give us the same answer. Fine. Now, so therefore what I can do, I can consider that the root of the equation to be alpha and alpha into r. Fine. I could have considered alpha by r as well. So now from here, what is the sum of the roots? Sum of the root is alpha into 1 plus r, that is alpha plus alpha r. So if I take alpha common, it becomes alpha into 1 plus r, and that is minus b by a. So if I square it, it becomes alpha square into 1 plus r whole square, that is equals to b square by a square. And then the product, that is alpha square r, that is equals to c by a. Now let me do what? Divide 1 by 2. So if I divide 1 by 2, I get alpha square cancelled. It will become 1 plus r square by r, and b square by c, obviously 1a will get cancelled, so therefore it will become b square by ac. And from there, if I just do some side transpose, we can see that we get our required answer. Fine. Small and simple problem. So it is not always necessary that whenever you have an expression to prove in any given problem, it has to be a very big problem. Last problem, number 8. Now this one is a simple problem, but obviously a little bit tricky, more like one of those competitive exam reasoning problem kind of. The problem is, two candidates attempt to solve a quadratic equation of the form x square plus bx plus q equals to 0. One starts with the wrong value of p and find the roots to be 2 and 6. The other starts with the wrong value of q and finds the roots to be 2 and minus 9. Find the correct roots and the equation. Now, it is told that in the first case, he starts with the wrong value of p, but it is not mentioned anything about q, so therefore the value of q is intact, it is right. And also in the second case, the other one starts with the wrong value of q, so the value of p is intact. So therefore, let me consider that p dash and q dash be the wrong values of p and q. Now in the first case, the equation which was taken was x square plus p dash q plus p dash x plus q equals to 0. Means the value of p is wrong, but value of q is all right. And the person got the roots as 2 and 6. So therefore from here I can say what is the product of the root. The product of the roots is 12, and we also know that q is equals to 12 because q is basically product of the roots. And in the second case, the value of q is wrong, but the value of p is correct, and the roots were 2 and minus 9. So from here I can say that the value of p is minus of 2 plus of minus 9, because p is basically sum of the root, the negative of sum of the root. So therefore p is 7. Correct. So therefore what is the actual equation? The actual equation becomes x square plus 7x plus 12 equals to 0. X square plus px plus q equals to 0. So therefore it is x square plus 7x plus 12 equals to 0. Fine. And then if I do the middle term factorization, I get the actual roots to be minus 3 and minus 4. Fine. Last one. Oh, sorry, this is the last one. So therefore this is our class. This concludes the chapter quadratic equations, and we will start off with limits and derivatives in the next class. So thank you.